going to learn today what the stem and leaf plot is and how to construct one. We're going to look at how we can get the median and the mode from a stem and leaf plot. And we're also going to look at some things called back-to-back stem and leaf plots. Let's go. First of all, sometimes if you're given a whole bunch of numbers, a whole bunch of information about something, it can be hard just looking at the numbers to get any information about the group. So something like a stem and leaf plot is a way of representing our data visually so we can see where our data sits and how it is ordered. So here's an example of a stem and leaf plot here. And the first thing to have a look at is this key. This key tells me that if there's a 2 in the stem and a 4 in the leaf, it represents 24 people. So looking at my plot, this is the stem here, and these are the leaves. So each one of these leaves represents a different number. If I were going to write the numbers out, the first number with a stem of 1 and a leaf of 2 would be the number 12, according to this key that I've been given. The second number with a stem in 1 and a leaf in is the 16. 6 would be the number 16, and I could keep going. 22, 23, 24, 27, then on to the stem of 3 and the leaf of 1, etc. So all a stem and leaf plot is a way of organising your data visually. I can see straight away from looking at this stem and leaf plot that I have far more data in the 30s and 40s than I do in the 10s and 20s. So straight away I can get an idea of how my data is distributed. It is similar to a bar graph or a column graph on its side, but I can actually see what the numbers are. So I've got a little bit more information than just a histogram, which we'll look at next lesson. So let's have a look. Here is an example. Actually, I'll go and do a different one first. Let's have a look at this example here. I've got a set of data, and these are all decimals. So I'm going to organise these numbers into a stem and leaf plot. The first thing I have to do is decide what my stem's going to be. Decide what will be the stem. So generally speaking, not always, but generally, the final digit is your leaf, and what comes before the final digit is your stem. So in this case, my stem is going to be 0 point something, going up to, what's the highest number? 63, so 6 point something. So I've decided that my stem will be the units column. And second thing I need to do is say what is the smallest and the largest number. That will tell me where my stem goes from and to. So my smallest number is this first one here of 0.3, so my first stem is going to be an O. And my largest is 6.8, so I need my stem to go up to 6. 1, 2, 3, 4, 5, 6. And I'm going to write my key before I forget. Let's just choose a number. I'm going to choose the second number, which is 2.5. And I write the key like this. 2 in the stem and 5 in the leaf represents 2.5. Okay, let's go. We'll start writing in numbers. I usually write these in an ordered way because it makes life easier. And I'm wrong already because there's a 0.1. So my first should be 1, 1, another 1, and 3. Let's go to the 1s now. So I've got 1.0, that'll be the lowest. 1.4, another 1.0. And 1.4. Okay, I'm just going to pause this and I'll do the rest of the stem and leaf plot so you don't have to sit through it. Okay, that's a bit better. I have also noticed that I had another one up there, 7.5. Alright, so there's our stem and leaf plot. If I have a look at it, at the pattern of it, I can see that most of my data falls in the 3s and 4s, and that it's roughly symmetrical. Not perfectly, but roughly symmetrical. B says find the median. Do you remember what the median is? It's the middle number when the numbers are ordered. So by putting it in the stem and leaf plot, effectively we have ordered it because it's going 0.1, 0.1, 0.3, 1.0, 1.0, etc. So I have my data ordered. I just need to find the median. Remember, the median is the middle. So I need to know how many data points I have to be able to find the middle one. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and 28. 28 pieces of data. So that means that my median will be in between what? Half of 28 is 14. So the 14th and the 15th. So let's see if we can find the 14th. The first will be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th is the number 3.3. And the 15th will be the one next to it, which is 3.4. So to find the median, it will be equal to the average of these two numbers, 3.3 plus 3.4 over 2, which gives us 3.35. So there's our median. Let's have a look and see if I can use the stem and leaf plot to find the mode. Well, the mode is the one that happens the most. So what I do is have a look and see if there's any numbers that are repeated next to each other. 3 and 3, so 2.3 and 2.3 happens twice. 3.3 and 3.3 happens twice, but look at this, 4.1, 4.1, 4.1. So the mode is 4.1 because it occurs 3 times. And we've already looked at the data as symmetrical or skewed. Okay, I want you to pause there and go and find an example of a stem and leaf plot in the exercise. Find one that's not back-to-back. So we're in 9H and we're doing even-numbered questions. So go and find a normal stem and leaf plot to practice and then come back. So I'm going to keep going, but you pause this and come back. Alright, let's have a look at back-to-back stem and leaf plots. We use back-to-back stem and leaf plots when we've got 2 sets of data that we want to compare side by side. So in this example here, I've got the losing scores of 30 games of football and the winning scores of the last 30 games of football. So on this side I set up my scores using the normal way that I've just taught you with the stem and leaf plot. So this represents a score of 74, 75, 78, etc. Then for the winning scores I have to work a little bit backwards. The stem stays the same, but now 8 in the stem and 1 in the leaf represents 81. So I have to think of it in the reverse. 95, 97, 101, 104, 104, 108. So you can see how it goes from smallest to largest in that direction, whereas on this side it goes from smallest to largest in the other direction. So that's basically all the back-to-back stem and leaf plot is. It's useful because at a glance I can see that they're very different distribution of scores. These scores are all clustered around the 70s and 80s, whereas these scores are sort of clustered above 100. And you would expect that since these are the winners and these are not the winners. So now that you've had a look at one of those, go and complete that exercise 9H even numbers and have a go at back-to-back as well as a normal stem and leaf plot. Have fun. Bye.